In this question, we're told that a robot is programmed to perform a random walk along a number line. In each minute, it moves either +1 along the number line, so that's moving to the right, with probability 2/3, or -1 along the number line, moving to the left, with probably 1/3. Each move is independent of all the previous moves. Given that the robot starts at position 0 and that the random variable y represents its position after 3 moves. Okay, so let's get a diagram. Okay, so here's a diagram and the robot starting here at 0. As I keep on reading, we're told that the random variable y represents the robot's position after 3 moves. So it can do a maximum of 3 moves to the right, a maximum of 3 moves to the left, or some sort of combination where it will land somewhere in between -3 and 3. So this is my visual to keep track of what's happening. We're asked to show that the probability that y equals 1, so the probability that the position after 3 moves is 1, we need to show that that's 4/9. Okay, to do this, I'm going to try and think of all the possible journeys that this robot might take. So I'm going to try and be systematic. It can move to the right 3 times, or it can move to the right twice and left once. There are 3 ways that can happen. And that's with the left move being third, or the left move being second, or the left move being first. So there are 3 ways that we can get 2 moves to the right and 1 to the left. All 3 of them mean we end up in the same place. 2 to the right and 1 left leaves us on the number 1. Similarly, there are ways where we can have 1 move to the right and 2 to the left. Either I move right first, or I move right second, or I move right third. And then the only other combination is 3 moves to the left. So, okay, now let's find the probability of these things happening. The probability that we move to the right 3 times is going to be 2/3 times 2/3 times 2/3. 2/3 cubed. Right twice and left once is 3 times 2/3 squared times 1/3. And similarly, we can produce the probability of each of these things happening. All right, and now obviously this is the calculation. The actual probabilities: 8/27, 4/9, 2/9, 1/27. Let's also track the end position. So we either end on 3, 1, -1, or -3. All right, so a lot of information here. It may well be useful later on in the question, but part A wants us to show that the probability that y equals is 4/9, and we have done that. The end position of 2 moves to the right and 1 move to the left is going to be 1, and the probability of that happening, as we've shown above, 4/9. Part B of the question asks us to show all of our working and calculate the variance of y. So this is why it was useful doing all of that systematic work ahead of time, because to find the variance of y, we need the probability distribution of y. That means we need all the possible outcomes and the probabilities associated with them. And that's basically what we did in the first part. So here we are, straight away, quite a few marks for being able to produce this distribution. To find the variance, we need to do the usual things. We're going to find the expectation of y, the expectation of y squared, and then a combination of the two. So the expectation of y is -1, while the expectation of y squared, that's going to be -3 squared times 8/27, -1 squared times 4/9, 1 squared times 2/9, and 3 squared times 1/27, 11/3. Variance is the expectation of y squared minus the expectation of y, and that gets us an answer of 8/3. Okay, that's our variance. So 6 marks there. Most of them we did the hard work up in part A of the question. Next, it's stated that if the random variable d represents its distance from position 0 after 3 moves, explain whether variance d is the same, greater than, or less than variance y. So this is a slightly different distribution. Here it's just the distance, not the final position, but the distance. So when it lands on 3, the distance is 3. When it lands on 1, the distance is 1. When it lands on -1, the distance is still 1. And when it lands on -3, the distance is still -3. So this distribution, this D distribution, only has 2 possible distances. It's either 3 or it's 1. And now the probability for 1 will be a combination of the probability for -1 and +1. And the probability for 3 is a combination of the probability for -3, +3. So this is a quite smaller distribution. There's only 2 possible outcomes for it. We're trying to compare the variance for D with the variance for Y. Well, straight away, just by looking, I know that variance is a measure of spread. And the outcomes for D have a lot less spread than the outcomes for Y. But we need to show a bit more of a formal approach of why I might anticipate that the variance for D is smaller. Okay, let's just rely on the formulas as we usually would. So I'm going to try and find the expectation for D. Even without finding the expectation for D, I know it's going to be greater than -1. The expectation is somewhere in between 1 and 3. Expectation for D is greater than the expectation for Y. However, the expectation of D squared is to be equal to the expectation of Y squared. Let's not forget, when we square, the values become positive. So the -3 became +9. The -1 became +1. So the expectations of D and Y will be exactly the same. Well, that means if we were to calculate the expectation for D, I'm subtracting the larger number. Expectation of D squared is bigger than expectation of Y squared. So expectation of D matches the expectation of Y. I'm subtracting more away from it, which means the variance is going to be smaller. So that should be enough to show that the variance of D is less than the variance of Y.